This video is going to show you how to perform the steps of the Gauss-Jordan row reduction method that's presented in our textbook, which is a modified version from what you might find out there on Google if you just did a YouTube search, that type of thing. The intent is to make the process a little bit easier because we will remove fractions and decimals and not allow them back into the problem until perhaps the very end, when your answer may end up being a fraction or a decimal. But before getting into those specific steps, I'm going to go ahead and just show you the process and explain some of the vocabulary using this first example that's found on page 290 of your textbook. And our equations are x plus y equals 4, x minus y equals 2. We could solve this system using graphing. We could solve this system using the algebraic methods of elimination or linear combination. But if you are asked to use the row reduction method, you need to convert these equations into matrices, which is step number 1. To do that, what you need to know are the coefficients in front of each of the variables and your total. And you're going to create rows of numbers that correspond to each equation's coefficients. And so we'll start with the x's, then the y's, and then the totals. So my first row of my matrix would be 1, 1, and 4 to represent the first equation. The second row is going to represent the second equation, again starting with the same variable x, then y, and then the total. So I will have a 1, a negative 1, and a positive 2. And then you put these brackets or straight lines on each side to show the beginning and end of your matrix, and that is step number 1. When we are working through a row reduction process, we are using what's called a pivot number. The pivot number starts off in the first row, and it's going to be the first number as you go left to right that's not a 0 will be your pivot number. So that puts it right here in this upper left-hand corner where this 1 is located. That designates then a pivot row and a pivot column. We are going to progress to another matrix, and the pivot row remains unchanged. So you can actually go ahead and set up the next matrix so that your pivot row has been transferred over in its exact location, meaning the first row in this scenario. The other row that you have is the non-pivot row, and what we want to do is take a look at the column that our pivot number is in, and we want to make sure that the other number, the number that is not a pivot number, turns into a 0, and we call this clearing the column. To clear a column simply means that once you've moved to the next matrix, the only number that isn't a 0 was the original pivot number you started with. So we need to perform some type of arithmetic between these two numbers in the first column to create a 0. You can add the two numbers together, you can subtract the two numbers together, you could multiply one of the numbers by something, multiply the other number by something, and then add or subtract. It's the only thing you can't do is divide. So we're not going to be dividing or multiplying by 0. So we're going to take, if we take 1 in the first row and take 1 in the second row, if we just subtract them, that would create a 0. What we're going to do is write that set of directions between the two matrices, and this is what we call the row operation. Instead of saying we're going to take 1 minus 1, we talk about the location of that number. So we would say this is our row 1 number, and then this would be our row 2 number, and by subtracting them, that would create a 0 in that first column. Use an arrow to show that my answers to this set of directions are going to be in this row of the next matrix. And what you now have to do is go column by column, which we have 3 columns here, performing that set of directions. So we're going to take column number 1, row 1 minus row 2, which is 0. Column number 2, we have row 1 minus row 2, so 1 take away negative 1 is actually 2. And our third column is 4 minus 2, row 1 number minus the row 2 number, which is a 2. And that completes what we call a cycle. What we're going to do next is look at the next matrix that we have. We're going to go to the next row and identify a pivot number here. So our pivot number again is the next row, first number that is not a 0, which would put it as the 2. What that's going to mean is that now our second row contains the pivot number. So our second row is going to be the row that does not change. So we're going to transfer over 0, 2, and 2. And what we want to do is focus on the column that 2 is in, that pivot number is now in. And we want to make sure the other number turns into a 0. So we have to think, well, if we take 1 plus 2, that's going to be 3. That doesn't give us a 0. If we do 1 minus 2, that's negative 1, which is not a 0. So right now, these numbers are not as they need to be to write something simple like row 1 plus or minus row 2. We need to actually multiply one of these numbers by something so that when I add or subtract, I can get a 0. So if this 1 could be turned into a 2 using multiplication, then that would allow me to subtract this 2 and get a 0. So you have to think of what would you multiply this number by in order to create either the same number as what's below it or an opposite sign, so an opposite of the number that's below it. So I'm going to try to take this times 2. So what I'm going to write in my row operation space is what I'm doing to that row number. So I'm going to take 2 times the number that's in the row 1 location. So I write 2 times R1. So if I take 2 times R1, that's going to make this turn into a 2. And then all I'd have to do is subtract the number that's in the row 2 position. And this becomes my set of rules I'm going to use with each of the columns, even though I use that middle column to figure it out. So I'm going to start off in column number 1. I'm going to take 2 times the row 1 number and subtract the row 2 number. So I'm going to have 2 times 1, which is 2, minus 0. And that answer would then be 2. And you record the answer in that column 1 position of the next matrix. Go to the second column. Take 2 times the row 1 number, brings us up to a 2. Subtract the row 2 number, so 2 minus 2 would be 0. Record that in the column 2 position of the next matrix. And column 3, if we take 2 times the row 1 number, that'll bring us up to an 8. Take away the row 2 number would bring us down to a 6 for a total. Because we have no other rows to move down to, the cycle of move down a row, move to the first number that's not a 0, and identify your pivot number is now finished, and we are at the final step. The final step is to go back and look at where the pivot numbers locations used to be. In the first row, the pivot number was located in that upper left-hand corner. In the second row, the pivot number was the middle value. And what we're going to do is one row at a time, figure out what we would need to multiply by to create a 1 in the pivot number location. So right now the pivot number in this top row is a 2. If I take 2 times 1/2, that's going to turn it into a 1. So if I take 2 times 1/2, I have to do that same thing to the entire row. So I'm going to say I'm going to take 1/2 times that row 1, and that's going to give me a 1. 1/2 times 0 stays 0, and 1/2 times 6 turns into a 3. The second row, I have another 2, which means my directions for my last row, last step here, would be that every number in this row, if I take it by a 1/2, that's going to make sure the pivot number turned into a 1. So starting here at the 0, 1/2 times 0 is 0. 2 times 1/2 is a 1. 2 times 1/2 is another 1. Now we have our answer. When we first started, we were letting x be represented by the first column, y was being represented by the second column, and the third column were our totals or our answers. We have that same type of thing happening throughout the entire problem. So these are our x's, these are our y's, these are our totals. And if we go back and just read one row at a time, we have 1x plus no y's is equal to 3. So if you just have 1x equal to 3, that's going to be your answer for x. The second row says 0 x's, 1 y equals a total of 1. So 1 y equals 1. So y is a 1. So we now have found the answer to our system. The x coordinate is a 3 and the y coordinate is a 1. You should be able to check that using the other methods. You can graph these two and show that their point of intersection occurs at 3, 1. You could solve these with substitution or linear combination or elimination. And you should also get that x is a 3 and y is a 1, which is our point of intersection. You should also be able to just do an algebraic check. If you put a 3 and a 1 in place of the x and the y in both of these, it should give you their respective totals. And that is how you find the point of intersection using the Gauss-Jordan row reduction method.